then let's get going. So this meeting is being recorded, by the way. Everybody should be getting the notification that it's recording, but we'll have this public shortly after the webinar. So just want to say that out loud. For people I don't know on here, my name is Ellen. I use she and her pronouns. I'm a data visualization specialist here with the USGS in the water mission area. And all of my teammates are also on this call and they'll introduce themselves as well. We're here for, we organize the DataViz Collaboration Area of the USGS's Community for Data Integration, CDI. So whether you're here through CDI or whether you're here through Twitter or somewhere else, welcome. We're really excited to have you here. So I'm going to quick give an orientation. If you don't mind first, if you're not speaking, if you can mute yourself, that would be great, just so we don't have much background noise. Couple of other things you'll see up in, I think, the right-hand corner of your Teams window. You'll see, obviously, the big red leave button, but right next to it, there's also the mute button to mute yourself. The 3 dots right up here will give you some device settings if you're having trouble hearing or anything, so check that. And if you're really having troubles, or if you want to ask a question and it's not urgent, then put it in the chat. Or if you want to comment and see if anybody else in the audience is thinking about something, put that in the chat too. We're really hoping that the chat is going to be a lively place for some conversation, in addition to watching and seeing and absorbing the workshop that we're going to go through today. So that's the quick orientation. I'm going to give a test to see if this goes through. So today we're really, really proud to welcome Cédric. He is going to be introduced more fully later, but for everybody who saw this amazing graphic and was like, I wonder how that gets made. Let's see what's happened. You're in the right spot, so welcome. Here's our quick agenda for today. We're in the middle of giving an orientation right now. I'm going to spend a few minutes and do some live polling for folks who've used Sli.do before, just to sort of see who's out there, see what familiarity. We have Cédric has sent some questions in and we've included 1 or 2 of our own just to sort of get to know each other through this weird remote distance webinar situation. And then at the very end, we'll have Q&A, questions, announcements, and then we're going to stick around and chit chat. The whole point of hosting these webinars is to get to know each other. So please, if you have time and interest, you're welcome to stick around and chit chat with all of us. Oh, thank you, Vanessa, for letting me know that my audio is breaking up. I don't know if it's from me, but I will speak a little slower. Okay, we've already gone through these tips. Mute yourself, Q&A. During the Q&A, feel free to type your questions into the chat, and C and I will read through them and say them out loud if you don't want to, or if you want, you can raise your hand using the raise hand function right here, and then we will invite you to unmute yourself and you can talk. All right, so I can't remember, is somebody else giving this quick orientation to CDI itself, or is that also me? Either way, I'll go for it. Okay, sounds good. Thanks, guys. For those of you who are brand new to a CDI meeting, welcome. We're really excited. We are an open community for data visualization practitioners, mostly within the USGS, but open to anybody. We are hoping to gain an exposure to diversity of skills, tools, perspectives all around DataViz. We also are trying to serve as a resource for folks about guidelines, best practices, and that's why we host these webinars, to learn those. And most importantly, we're here to connect with you. We want people to know each other, and the best way we learn is with each other. So this is the hub for doing that. And we're really happy to have you. All right, so now we're going to do some quick live polling. For folks who have their phone with you, you can use your phone and keep your screen up watching while inputting on your phone, or you can take the link, which I think is going to go in the chat in a sec, thanks to Amy, and you can do it on your desktop. But basically, I'm going to have some slides up here. You'll have the opportunity to answer them, and your answer will populate with everybody else on the screen. So let's get into it. All right, most of these questions were provided by Cédric. So we want to know, first of all, what chart type would you like to see more often in the world that you see a lot around? Do you have a favorite that you wish more people used? Again, you can use your phone to go up to the QR code here, or you can go to Sli.do.com and the password is ggplot. Oh, you got the right audience with violin plots. Maps. Interactive, dot plots. I think this is a very USGS heavy crowd, so I'm seeing maps right in the middle. That works. Yeah.
Even more maps, yeah. We have seen so many maps during the last 1.5 year.
Seriously.
I mean, it's about what you see more often. Okay.
Anything but pie.
I have no maps today, sorry.
Yeah,
especially no interactive maps.
Cedric, do any of these stand out to you?
I mean, it's interesting. Not sure if people really got them more often, because I also see bar charts. I think networks are coming more and more because also computationally easier and easier. Lollipop charts, yeah. So my favorite chart type, I think currently, is dumbbell plot. Also not that rare, but I'm kind of like really doing it a lot currently for all types. Yeah, maps are great, of course, but only if you have the data for it. That's often the problem. Dot plots, yay, we will see them. Heat
Yay.
maps, yeah, all good.
All good. All right, we're going to go to the next one. You can still answer those and we'll go back to them later, or we have the data available. But the next question that we want to know is, what do you want to see less often? Answer number 1, pie chart.
Yeah, if it's about pie charts, I'm always curious if it's just like a general rand mode or if it's really, I mean, there's a case for pie charts. So I'm definitely not on the never pie chart team. Bar charts, less bar charts, interesting.
Less bar charts.
Boring ones, that's a good one.
They can get kind of like monotonous.
Oh, broken axis. I mean, it's not a chart type, but broken axis is a good one. 3D pie, yeah. Add to these 3.
Those weird radial plots.
Oh, joy plots. I think the correct name now is ridgeline plot. Yeah, I guess seen too often, maybe.
Yep.
Yeah, there's a bit of background story
about
yeah, we shouldn't call them joy plots. In the beginning, they were called joy plot, but it goes back to the joy division, which was during the Nazi regime. I can't fully get the story correct, but yeah, it's connected to dark, ugly times. So we call them ridgeline plots now.
That is super good context. I actually did not know that history, and
yeah, Klaus Wilke. I'm not sure if he. I mean, I don't think he invented these charts, but he made them very popular with the ggriches package, and he wrote about them. About this, I can have a look. I can share it with you.
Fascinating. Yes, would definitely love to read more about that. In the meantime, I'm going to go to the next question just so we can give you time to walk through your presentation too. Okay, everybody, this is not a word cloud. This is an open text. What's the latest misleading chart that you've seen? And if you have room to add, can you tell us why it was misleading? Or what was a misleading thing about it? Any COVID one that says data is? Are you a data R person? The person who wrote that? 2 different axes. Yeah,
2 different axes is a difficult one. I get so often the request to do double axes.
Yeah.
It's always, sometimes it's just no way around, fortunately. So here's the link to the joy plot, ridgeline plot discussion.
Awesome, thank you.
Yeah, too many variables, definitely. Especially for scientists.
I appreciate the person who said rainbow color scales.
Yeah. Oh, I missed that. Yeah, that's good.
The USGS has some really, really rainbowy color scales.
Yeah, all weather and maps often as well, right? But also medicine, it's a lot. And I heard once a talk about it that there's kind of like really problematic because it makes it difficult to see the important bits. So more severe than consequences in our case, or at least in my case. Not sure about your rig, but I rarely deal with people who have a look at my visualizations, have to live or die. Fortunately.
Fortunately. Oh, a 0 at the top. Whoever said that, yes.
0 at the top. Okay.
If it like an inverted scale.
Yeah, I just often see it for design reasons. Like there was this bloody one where the blood was dripping.
Yeah.
Or if there's kind of like it's about ocean depth or something. But there you could also argue it's minus. So
I guess it has to fit the reality of the data.
yeah.
All right, so I'm gonna keep going just for
Choropleth.
brevity.
Yeah.
Chloropleth, yeah. We can definitely come back to these. Okay, so we're gonna shift a little bit. We're gonna talk a lot about ggplot today. So we want to see how familiar are you with ggplot? ggplot is life.
It's a bar chart race. Okay. Wow, that's very heterogeneous.
Yeah, really good spread.
Okay, we have a few people who never used it. This might be a tough one, but I mean, it's more than about letting you or giving you some inspiration what's possible.
It should have a rubber ducky, you're right. Thank you, whoever wrote that. All right, let's go to the next one. So for the folks who are more familiar or have used ggplot at least once before, what task or code blocks do you search for or Google the most often? Yeah. Most of them. Listen, I'm in that category too.
Oh, what does AES mean? Okay, we can clarify that maybe. It's not on my list, but that's an important one. Getting aesthetics right, getting the connection, then suddenly ggplot makes a lot more sense. Yeah, legend formatting, yeah. They have a lot of own syntax. Okay.
Oh, Vanessa, I'll answer that question in the chat later. This is basically requesting control from somebody else. All right, you can keep submitting again, but I'm going to keep going. So
why is my blood gray? That one I want to highlight.
Wait, what did you say? Which one was it?
Why is my plot gray? I'm not sure if it was a joke about the theming, but I like it.
I do like that. All right, what is your favorite ggplot2 extension package?
Oh, a ggElement, okay. Yeah, a classic ggRepel. Patchwork, yes.
I
would have a very hard time to decide for one, but Patchwork is for putting graphs together, and it's really cool.
That's
awesome. Basically, I'm not sure what you used before, maybe cowplot. Cowplot, now it's coming up here. So Patchwork is the simple cowplot, basically.
Gotcha.
It's also from Thomas Patchwork.
ggFX.
Yeah, ggFX, the new one. Yeah. Okay. Yeah, for everyone who wrote down cowplot and didn't hear about Patchwork yet, check out Patchwork. If we can share the list of ggplot extension packages. I mean, there's a pretty good official page to look them up. Just Google ggplot2 extensions and you will find a filter homepage where you can filter based on whatever you are searching for. I also will at least cover a few. ggtext is great. Yeah. Cool.
Yeah, this is awesome. All right. I can't remember if we have another one.
Thanks,
and I think we don't. So I'm going to hand this over to C because we're going to shift from me talking to other people talking.
All right. Hi, everybody. For those of you who don't know me, I'm C or Colleen. I use they, them pronouns. I'm a data visualization specialist with the Water Mission Area and one of the coordinators for this CDI Data Viz Collaboration Area. So I'm pleased to introduce you all to Cédric. Cédric's a computational ecologist with a passion for design. He brings together his expertise in data analysis and visualization in R as a freelance data visualization specialist. I personally first interacted with him earlier this year via Twitter, when for the month of April, he co-organized this 30-day chart challenge, where people all over the world shared a data visit day via social media. And that was a complete blast to participate in with the Water Mission Area Data Science branch and the CDI community. And I hope and openly invite everybody to join us next year for next April. And then personally, as a ggplot lover, I'm in awe of Cédric's ability to make complex and visually stunning charts entirely in ggplot. And I'm really excited to learn some new tricks today. So with that, I'll let you take it, Cédric.
Oh, thank you so much. Thank you for the introduction. Yeah, it was great to have you during the 30-day chart challenge. We're really proud also to have the USGS with us, and I really like your stuff as well. So I was really kind of like having a bit of struggling when I was preparing the slides, because I was like, you know already everything. So it's good to see that there are also people here who are not using so much ggplot. Now I'm just trying to find where I can share my screen. Oh, this obviously here. Okay. So now I have only one monitor, so I have to close the chat and I can't see you then. Or I think so. Let's see. Okay.
That's totally okay. Maybe if there's a chat that is for you that might be important, we'll say it out loud. And gently interrupt you. So don't worry about it.
Yeah, it would be good to switch also. So I sent around the link to the repository. Hi, everyone, first, for everyone who came a bit later. I sent around the link to the repository. There's also the link to the slides and to the notebook. Maybe I quickly show it now before I start with the talk. So that's the repository. Oh, can you see that? It's slow, but it's there. So here you will find the slides and a notebook. So I'm talking a bit, these are the slides, talking a bit about the code as well, but I'm not really going through every detail of the code. So we can have a look later if we still have time. And the idea is that I highlight specific things I do, tricks, or also only the packages you need to do them. And you have the full code to reproduce them. So this is the notebook. So here you always see the code and then the plot. Okay. And I hope you can follow along, but you can also just listen to me and enjoy and then have a look later. Okay. So I'm talking about beyond bar and box plots. And so this will be a technical thing and also a lot of coding. So we already had a nice introduction. So shortly about me from my side. So I'm still an academic working at the IZW in Berlin. It's the Institute for Zoo and Wildlife Research here. And I'm also working as a freelance data visualization specialist, and I'm doing consulting, I'm doing coaching, and I'm doing mostly coding. So I'm now also using a bit more designy tools, but as mentioned, most of my visualizations were done almost 100% or 100% in ggplot. And because of that, I'm also using a lot of other R packages, as you can see here on my monitor or laptop, here in the image. Okay. So let's get it right. So this is the link to the slides. You should see them in the chat as well. The upper one is the shortcut if you don't want to type the long one, but the long one will be the permanent one. We start with a quote from Anscombe from 1973. And I found that was reading through the literature. It's a prominent one. And I think this is also something most of the data visualization people will tell you. Make both calculations and graphs. Both sorts of output should be studied because each will contribute to understanding, which means only the graph itself will not help you, but also the calculation itself might be not enough to really aim or to get understanding of your data and what's going on of the patterns. And why I'm pulling up Anscombe here. Anscombe is quite famous for the Anscombe's quartet, which is a set of 4 data sets, which have the same summary statistics along the 2 variables, so x and y, with regard to the mean, the standard deviation, and the correlation of these 2. And as you can see, also with the fitted lines, the regression lines does look the same. But you also see that the data sets are quite different. So while the first one, the Roman 1 here in the top left, really kind of like the line is following the data, or the data is dictating the direction of the line. We see this curve behavior or pattern in the number 2. We have one outlier on the y-axis in panel 3, and one outlier on the x-axis on panel 4. And if we would not plot these as a simple scatter plot, we would not see that these data sets are different, and that we might not want to use a linear regression, or we might want to have a closer look at the outlier or remove the outlier whatsoever. There's a new one of these Enscombe quartet. It's called the Datasaurus dozen. So there are 12 data sets and this T-Rex data set, and they have basically the same idea. So we have a bit more shapes here, but basically we can draw on a scatter plot with X and Y and still have the same summary statistics. So you can see here a star and the T-Rex and some circular data, some X shapes and all kind of different things. And again, the story is the same. It's important to look at the data as well in a visual way, not only in the summary statistics. And most of you may know this paper already. This is where the title for my talk also is coming from. The title, the paper by Tracy Weisgerber and colleagues, Beyond Bar and Line Graphs. It was published in 2015 in PLOS Biology, and it was one of the first data visualizations paper I came across. So I was a PhD student back then, or maybe not even yet. And yeah, I was pretty impressed because I was aware of that actually, but I was seeing a lot of bar graphs, and bar and line means here the dynamite plots. We will see a bit later how they look like. And I was always wondering if there's nothing better to use. And this was a scientific paper published in a biology journal, which was only about design and theory of how to represent data, which I found very impressive back then. So maybe this was a new trigger for me doing data visualization as well, or digging deeper here. And this is one of the figures from that paper back then. And here on the left hand in panel A, you see these dynamite plots. So this is a bar plot with some standard deviation or standard error, you don't even know. And in the panels B to E, you see corresponding data sets. They both on the left, the black bar, on the right, the white bar. And all of them, again, similar to the Enscombe quartet and the Datasaurus dozen, will lead to the same bar plots. And here you can also see we have outliers in panel C, for example, or bimodal or unequal sample sizes. So this is one of the charts I made for the 30-day chart challenge. Why dynamite plots are terrible and why you should use something else. You may have seen in the announcement the Drake version. Some people then told me, and I wasn't aware of that Drake is not someone we want to support, so that's okay. So I turned to someone we want to support, Shrek. And this is actual data on Shrek. I had no Drake data in the original one, so this actually fits better. And here you can see in the upper, the domestic box office of DreamWorks movies. And these are so-called dynamite bars showing the mean values of the domestic box office. You can see that the Shrek movies have a higher domestic box office, but what you can't see in the upper plot is that the number of movies differs dramatically. So Shrek was able to have these high box office revenues with only 4 movies, while the other movies of DreamWorks are, I don't know, 20, 30 movies altogether. And if you take a closer look at the lower plot, which we call the rain cloud plot, then you can see with the single points and also with the box plots that there's not even an overlap. So which means even the worst Shrek movie was bringing in more money than all the other DreamWorks movies until then. So this is, I think, a nice illustration why these dynamite plots or bar charts in general can be misleading. There's also an initiative, it's also a bit older now, which was actually a Kickstarter project, and they call themselves Barbar Plots, or the project Barbar Plots. And you can have a look on their page. And I'm not going to play the video, but they have a neat homepage where they have a funny Kickstarter video, some backgrounds. They wrote letters to editors of scientific journals to make them aware that these Barbar plots, how they call them, dynamite plots, are a bad thing to do, and that they should push forward that authors don't use this kind of chart type, but a different one. And you can even, I'm not sure if still, but there were also some shirts and stuff, so some merchandise. And what they wrote to the editor, for example, I'm just highlighting here one sentence, is that bar plots reveal very little about the distribution of the data, as we have seen with the Shrek example. And also, which I found very interesting, is a further issue is that of the bar itself, which implies that the base of the y-axis is meaningful. And that's not always the case. We will discuss that in a second as well. But I was mostly always focused on the distribution. And I find these, the argument of that the y-axis, the 0, we also have seen this in the answers that kind of like the axis should always start at 0. And I would not say this is a strict rule. It's also an important thing here. So this is the type of bar plot we're talking about. And the important thing here is that this is a summary bar. We are not talking about bar plots which state absolute numbers or percentages. We are talking here about mean, for example. So this is one plot I've already created in ggplot, so you can follow along with the codes as mentioned, but you could also just listen and go to the codes a bit later and have a look how in detail these plots were produced. But a few words on the general setup. So this is some ggplot code already. So we have loaded the ggplot library or the tidyverse already. And what I always do, and especially here, because I will present a lot of different plots, in the first line, I set globally a theme. And here I'm using the theme _ void, which means draw nothing. And you can already in there with the base family argument say what type of font you want to use. And then afterwards, with the theme update, you can update single elements. So what I'm basically doing here, because I have a very minimal theme, I'm kind of like starting with a blank canvas, and then I'm adding the axis text for X, the axis text for Y, a panel grid for the Y-axis, axis line, and I add a bit of white space because usually, especially with the theme void, we don't have any white space around our plot. And in the last row, you see that I create a color palette, a custom color palette with the Arcato color package, which is one of many extension packages which provide colors and color palettes for R. And here I'm using 8 colors with the name of bold, but I just picked 4 out of them. So what I'm doing here, if you have a look at these bold color palette of Arcato color, you will see that the last color is always gray, for example, and I didn't like any others of these. So this is a way how you can use these inbuilt palettes to create your own ones. So I basically return a vector of 8 colors, and then I just pick and order those which I want to use later. And the theme set and theme update is basically the same if you add always with a plus theme to your ggplot code an update of your theme, but you only have to type it once and it applies to all the following plots, which is pretty neat. So if you want to do the same plots, but for a talk or for a different journal, you can quickly change the settings for all the plots in the same script without making a search replace for every theme call you are doing while designing the plot. Okay. So back to our bars. So this is the mean value showing here. It doesn't matter what we show here in terms of the data set. It's a made up data set. It's also coming from Tracy Weisgerber, and it shows the data for 4 groups. And we will later see how the distribution of these data points looks like. But here we can just say, okay, the mean value for group A is somehow lower than for the other 3, and group B and C have the highest mean value. And this is something we should not do. In the upper, you see gm _ bar stat equals summary. So this is already a bit of ggplot code. And this is how we would add a bar with the summary call here. And the important thing is, that's one with the dynamite. This is obviously not even better, might be even worse because this could be standard deviation or standard error. And we have lots of other possibilities here, and here just a few I will show you later. So the first idea we could do is we show the raw data as these here barcode plots or B-swarm plots. We could also use different chart types. So here we see the ridgeline plots. Sorry for the person who doesn't want to see them anymore. You have to close your eyes for a few minutes. And the gradient intervals. And of course, we can also make these hybrid charts, I call them, like where we combine several chart types together, which is also the rain cloud plot, which consists of raw data, box plot, and a density curve. And this is the bar plot, which is fine. So if you replace the stat summary with the stat count, it just counts the number of of observations per group. And here you can already see that we have a very unequal n sample size across the groups, with group A consisting out of 50 points and group D only consisting of 4 single points. So this bar plot is totally fine. And here it's also important to include the 0 baseline, because the height of the bar is encoding the number of single observations, which means if we would cut it off, we would visually decrease the length of the bar, and thus the mapping wouldn't be correct anymore. So this is the typical Fox News bar chart blaming, where we just cut off arbitrarily, and then it looks like the difference would be very big or very low, depending on how the data looks like. Just a side note here, I mean, I don't want to talk about the end of the bar charts, but obviously for counts, they are very helpful. And nevertheless, bar charts are the most used chart type, I guess. And also, if you ask the DataViz experts, they will often say like, yeah, just do a bar chart. And the most important reason why not to use a bar chart is often diversity or variability in the charts, so that we don't see only bar charts for counts. But we have a lot of count data, and there's a lot of count data charts out there. And this is just one example to show you that it doesn't need to be always bars. You can also make lollipops, for example, which are not as heavy and as ink intense as the bar charts, for example. Here's another one I did for a Tidy Tuesday, a bit more colorful. It's a bit older. I'm not as happy with the colors anymore. I think some colors are a bit hard to read. But anyway, these are also lollipops and absolute numbers. So this is the distance for the Tour de France from 1903 to 2019. And with bars, this would totally look different. And we still have this timeline character and a bit minimal approach here. So next thing we can quickly do is, of course, a box plot, or the long version box and whiskers plot. And here we can see the argument of the bar plot initiative that the 0 is not always important, because if we want to show the mean value or the distribution of the data, we do not care so much about the 0 baseline, because the median, the mean, or whatever summary statistic you want to show is a point estimate. So it's not connected to the 0 baseline. And the box plots are super nice. I know that I'm kind of like known as being a hater of box plots, which is actually not true, because I think they're very elegant in collecting all the information in a few details. So for everyone who isn't aware of a box plot, the thick line in the middle indicates the median value. The box itself is the interquartile range, which means within the box we have 50% of the centered data. Then the lines are the whiskers, which are covering 1.5 times the interquartile range. And then if we have data which is beyond that threshold, we mark them as outliers by a point. And that being said, you need to know all of this. And my main point against box plots is often that I highly doubt that the general public, or maybe even every scientist, knows what exactly each of these geometric elements of a box plot actually means. So it's pretty easy to confuse people with these. I think for publication it's pretty good, but if you are talking to a broader audience, I definitely would explain the details of these, how to read them. And what we already know is that these groups have very different sample sizes, and this is not represented by these box plots. Of course, you could add a note that how big each group is, but it's also nicer to see it visually if possible. So a general coding note here again. So most of the plots you will see in the following use the same ggplot code, and I'm just changing the geom. So I'm saving an intermediate ggplot object, which I'm assigned to G. And in there, shortly, we call the ggplot main function, then the dataset, which is called data. And then there's the aesthetics. And because it came up in the questions quickly, inside the aesthetics is everything which is mapped to your data, which means if you have something which is contained in your table and you want ggplot to see it and to mark that value accordingly, you need to put it inside the aesthetics. Also, never use the $, syntax like data $group, data $value here, because this is the logic of ggplot. We have first the data, and everything inside the aesthetics is connected to the data. And because of that, we also have color and fill in here, and X and Y, because X and Y is obviously, if we want to draw a scatter plot or a bar plot or a box plot, doesn't matter. We need to have X and Y coordinates. And here I also map color and fill to the group. Then I override the breaks on the y-axis with the scale _y_continuous. This is already polishing here. I just want to have them fixed. And then I use my color palette I showed you in the beginning from the Arcato colors. And with the guide equals none, I just say don't draw a legend here, not for fill and also not for color. And I do both because depending on which geom we use, we might have a filling, we might have a color, or we might have both. And then, for example, for this box plot, I just add this geom, which you see also in the subtitle. And here specifically, we would not even need the fill group here. This is redundant. Sorry for that. So it's G plus GM box plot, and then I add a bit of transparency. I increase the size, which means a bit thicker lines, and the outlier size, so the dot was very small and hardly to see, so I increased the size as well. I actually don't like to use alpha, so this is another tip, and this is pretty new to ggplot. It came in ggplot version 3 last year. Time is flying by. I think last year. It's called afterscale, and we will see both in comparison here, and you might now say, okay, there's not much of a difference, but you cannot always use alpha. So on the left hand, you see that the grid line is visible in the box. This might be something you want to use here, so it's totally fine to use alpha here, but in some contexts, it's not possible to use alpha, but I still want to access the filling or the color to be different, and the afterscale function allows to do so, and this is also specified in the aesthetics. So on the right hand, I say like the fill should be also group, as I did on the left hand as well. But then I override the filling and say, okay, after you have applied my color palette, please use the lighten function from the color space package and make the filling lighter as originally set. So basically we can use the same color palette for both color and filling, but I can manipulate it on the fly. So I don't need to have 2 or 3 color palettes beforehand, but I can manipulate it or adjust it while coding after it's scaled. So which means in the scale, color, scale, fill, we use the same color palette, and then color space also has functions for desaturating the colors, darken the colors. There are packages which can inverse colors. And it's also very neat if you have more complex ggplots. You might want to use a different palette for fillings and for color. And if you now already a ggplot user, you know you can always have only one filling and one color. And this way I can use the same palette for both a fill and a color. I'm happy to explain a bit more. I also know this is a bit more confusing. And when I saw it for the first time announced in the news, I was like, why should I ever need that? And honestly, I use it for almost every ggplot I draw. This is a bit older. This is one of my first blog posts when I started working on the Tidy Tuesday. Oh, this was not intended. Okay. When I was working on the Tidy Tuesday challenge, or contributing to the Tidy Tuesday challenge. And this is just, I want to show you here that I was already thinking about, okay, how can we replace a box plot? What are the different ways of showing the distribution data? And this is also where kind of like the impression comes from, that I'm against box plots. And there were many comments saying like, yeah, how is your plot better than a true box plot? And yeah, I already brought up the arguments I have from my side, that this might be easier to read and also more informative in terms of sample size than the box plot. Nevertheless, the box plots are great in general. And this was the original contribution. So here I visualized the overall average. You could also use the median. I'm using the mean here with a line. And then I have these lollipops to the left and to the right. So to the left, if the mean is lower, to the right is if the mean is higher than the average, the worldwide average. And then we have smaller dots, which indicate every country. And then this little grid map, which indicates the different continents. Okay, but now let's talk about alternatives. And I'm first talking about those which summarize the distribution somehow, and we have also already seen the violent plots coming up in the questions in the beginning. So these are the violent plots. They don't look very exciting in the default, actually. You might know why they are called violence, but why are they great, or why are they better maybe or worse? You can definitely argue here, because the violent plot itself shows you a density curve, so it's scaled according to the distribution of the data. But of course, we lose the information, where's the median, where's the interquartile range, and we also don't have any information about the sample size here. If you don't like this default view, you can play around with the bandwidth. So in the gm_violin, which is a geometry from the ggplot2 package, so no extension packages needed, there's a BW argument, which represents the bandwidth. And if you play around with this, you can change the appearance of your plots. Here I just show you a few different ones. So the default is picked based on the data, and then as you can see, the higher you go, the less granular the violent plots look like. And if you get very low, you can see every data point in the bottom right. You could also scale them by count. It's a bit silly here because the group D is that small compared to the group A. But here now you can see, I mean, you cannot tell how many points are in there, but you can definitely see that group D is way smaller than group B and C. And these are, again, not as wide as the group A. But you need to interpolate these to kind of like see the full scale. But I do think that the violent plot used in this way, if you have differing sample sizes, that these can be very powerful. I asked a few days ago, I asked for examples in the wild, and actually I couldn't find many, especially outside of scientific publications. And Will Chase, a great designer and colleague, was explaining that he thinks that they are pointless most of the time, and I fully agree with him, and that the same thing can be done with the ridgeline plot. We already heard about it as well, and also that the horizontal layout might be easier to read than the vertical layout from violent plots. Of course, you can always flip them, but I think he has a valid point here. But nevertheless, I think we should have violent plots still on our list of potential chart types. So to overcome some of his criticism and also my personal criticism, I want to show you the stat half-I. So these are half violence, or called half-I's, or you could also, some would say these are just simple density curves. And these are coming now from an extension package, as you can see in the subtitle. So we see ggdist : and this is called the namespace in R, and then the stat half-I, which means the stat half-I is the function, the stat layer you need for ggplot to draw these. And these : just says, okay, this function is coming from the ggdist package. And you can see by default, this GM is drawing, or this stat layer is drawing half violence, and also adds these so-called slab lines, where the point already indicates the median, and then I guess the thick line is showing 66% of the data, and the thin line is showing 95 by default. I hope this is correct. Also, they have an argument. It's not called BW anymore. It's called adjust. And with adjust, you can make the same as with the violence. So here you can, at least on the right hand in group D, you can see each single data point. Unfortunately, I wasn't able to scale it by the number of sample points, but usually it's also possible. But somehow it didn't work out for me. One note here, I nudged them a bit to the left. So I go quickly back. You can see that there might be a bit out of order. So you can see that the line is always in the middle of the group. So this is again polishing, but I'm a perfectionist guy, so I don't like it. So what I do is I move them a bit to the left, and you can easily do this with a position call. So inside each stat layer or GM layer, you have an argument which is called position, and this takes a function. And this is not the position newt, it's the position nudge actually. Sorry for the typo. So there should be a G before the last E, and it's position nudge. And there you can control how you want to move your data points to the left if it's minus X, or to the right if it's positive X, or to the top or bottom with the Y argument. And here just moving it a bit to the left, so it's more centered again with the labels. And then because we don't have something like a box plot representation here, I don't really like to use the slabs. So you could say, okay, by default it's 66% and 95, so we show 50 and 95. You can do that. I'm still a bit, or not sure if this is a good idea, but what I like to do is just setting both widths to 1 so that the line covers the full range of the data, so I can clearly see, okay, this is the full range of the data, and then we keep the point for the median. And this is how you would do it. These dot width is referring to the size of the slab interval of the line, and then I increase the dot a bit to make it better visible. And here, for example, this is one of the visualizations for Tidy Tuesday, also a bit older. I would definitely do a few things different now, but here I use the ggdist stat half I. And as you can see, I have here a tiny white dot indicating the mean rating for each category of these ratings for Washington hiking trails, I think this was, and a diamond for the median rating. And so the diamond is coming from the line, and the density curves are coming from the ggdist. So this is only one geom to draw all of the things. And then I just added the dot and the text label for the median value. And here you can also see that I scaled them by the number of answers, because some of them are overlapping with the others. For example, the wildflowers and the mountain views for the 0 ratings, and some others are pretty flat, for example, the coast one. So it's possible. I'm not sure why it's not working currently for me. I found, while searching for violin examples, this one here, which I found pretty interesting. I mean, it's also half violins, but I found the idea, I never thought about it. It's a bit like the H pyramid, putting together 2 half violins to compare groups within each category and then category across. So here we have male, female, and light and dark, or vibrant blue respectively. And then we have Instagram, Facebook, and Twitter, and it's the age distribution of the social media followers. So we can compare female to male within each of the social media platforms and then across them, which I found a neat idea. Okay, coming to the next chart type. Guess I have to speed up a bit. Looking at the time. So ridgeline plots, it's from the ggwidgets package. I already mentioned it. They were called joy plots before. We shouldn't call them like this. If you want to have a look, I shared the link in the chat. So these are ridgeline plot, which is basically the same. It's half violence or density curves and then flipped. So this is what Will was referring to with the horizontal view, because it might be easier to read for you. I'm not sure about the science behind that. If it's really easier, we can also discuss it, or you can tell if you prefer that or the vertical ones. And the idea of ridgeline plots is also that they have this overlap, which is the idea to make it, to compromise it a bit and to show many distributions in one visual with maybe many categories. And you likely have seen them because they became very popular. There's one trick you can do. You can cut off the trails here so that you can really see that there's no data. And this you can do with the argument val_min_height and set this to 1%. So which means everything which is lower than 1% is not drawn. And then you also see where they start and end. And here's one example from my tutorial I have on my blog for ggplot, and I think this works very well. So here you see 2 categories per year as ridgeline plots. So we have blue winter and red summer, and then from the bottom to the top, the years. And I mean, it's only 4 years, so I wouldn't make broad claims here, but you can see that at least across these 4 years, the peak temperature in the winter seemed to vanish a bit. And we have this double peak and warmer temperatures in 2000. And we also see a bit of a shift on the peak in the summer temperatures to the right hand. Another example, very old one of my first personal, or maybe the first personal ggplot I did, is this one here. You see that I'm using the default ggplot colors, which I definitely not using anymore. It's about the most popular girl names in the US. So it's a famous data set many people play around with. And what I did is per quarter, so per 25 years, I extracted the top 2 names, and then you can see here nicely the shift. And what I wanted to show especially is that due to the diversity of names in more recent years, the number of names gets way lower. So you see the big chunk of Marys and also of Annas and Helens and Dorothys in the beginning. So in the 1900s beginnings, and then towards the 2000s, you see they get very low. And also it makes it, I think, quite readable due to the offset for each decade. So it's moving to the right. While this would be difficult, for example, if you plot them all on top, or also if you make small multiples, you might also have difficulties to directly compare them. So I think it works pretty well here. Also here you can play around with these. You can add a median line, for example. This is the code you need for that. You can, oh yeah, this was used by you from the USGS for the 30-day chart trend. So I was looking through by Sam Oliver actually here. And this was actually using this median line to show the distribution of daily stream flows here across the years. And the color indicates the rank here so that we can easily see yeah, which is the best or the greatest and the least of this year. And you can even go further. I actually never used this before, but I might now consider it because I've seen it, but rarely thought about it. So you can also color it, for example, by quartiles, which means this is basically representing a box plot. So we see that kind of like in the more intense colors, vibrant colors, we have like 50% of the data, and then we can see the tails. Here you don't need, or here you're not using geom witches, but the according stat underscore density underscore witches. As mentioned, I'm not going that much into the code, but I always want to highlight a bit of the code at least. And if you want to see the full code or you don't know what to do with this, then you can have a look at the notebook. And this is another example from the vignette from the witch line package, ggwitches package. So here we indicate the probabilities, so the low and the high probabilities, the lower 2.5% and the upper one. And all these kind of things you can do. So they can show more than just the distribution. Of course, you can also indicate thresholds or summary statistics. And this is how you would overwrite the legend to look like this. So this is a custom color palette and then also custom labeling. Okay, the next chart that I want to show you is again from the ggdist package. And this is one I really fell in love with, and especially in combination, maybe not alone, but these are called the interval strips. I'm not sure if this is the correct name as a chart type, but that's how I call them. And what are they doing? Yeah, they're again showing the distribution. So here we see that the darkest bit shows the centered 50% of the data, then we see 80% of the data in blue, and then in greenish it's 95% of the data. This is the default. You could override it here, for example, showing the 25%, 50%, 95, and 100% range. And I do like them because with not a lot of space, they show nicely the distribution. Also, if you have many points, when you struggle with other chart types maybe, and you can nicely combine them with other charts. So here, for example, how to do this, there's again this dot width argument you have seen already from the other ggdist layer. And here you can say whatever level you want to show. I like then to turn this into percentages because it's easier to understand for people, I hope. And maybe also a more descriptive name for the legend could be like, part of the data. Not sure what's the best name now, but you get it. So level might be also not the best here, but percentage proportion of the distribution covered or something like that. Okay, and here you need, this might be another trick. So you can overwrite the labels not only with a vector, but you can also use a function. So you write a quick function within the scale call where you say like, okay, paste together the x as numeric times 100. So this is because the ggdist stat interval returns a character. So we need to turn it into numeric, and then I can calculate the percentages out of it and add the percentage label. So you can always do that. If you don't find any other way to change the labels, you can always use a small tiny function, which basically use the number you normally see there, the 0.25, and then calculates it times 400 and adds a percentage in this case. And we could also add some more information here. For example, here with the stat summary and the GM point, I'm adding with the function median a circle, a white circle to indicate the median as well. So not only the middle 25%, but also the median value. And you could now, of course, also show the interquartile range, which is actually already shown by the blue box. As mentioned, you can nicely combine them. So here I combine them with these half eyes, and I think this is quite nice. And the half eyes also come with the slab interval, as you have seen. So here I'm using a diamond shape to indicate the median. So we have here now the information of these different levels where the data falls. Then we have a median indicator, and we have a nice density distribution. And again, here I'm working with the position nudge. Here it's spelled correctly. So I have to move it a bit to the side so they don't overlap. And it's a bit of fine tuning, but should be easily doable. And yeah, for the diamond, you need a bit of more code, but you could also go with a point if you don't like it. Just wanted to illustrate it. You, of course, also can change all these shapes within the extension packages as well. And for example, I've used this for challenge contribution to the storytelling with data challenge, where it was about distributions here. And this is showing the temperatures across months, across a year. And then you see it's exactly the same chart type as before. I have these interval strips, I have these density curves, and a point indicating the median. Last for this category is the gradient interval strips. It's another one from the ggdist. And if you like now these types of plots, check out the ggdist package. There are many, many more. It's actually based or built for uncertainty plots, but you can use it for all kinds of data. And this one is called gradient interval. And you can already see the other interval was with thresholds. And here we have a continuous band of the data. And we also get this slab interval for free, which we can easily get rid of if we want to, but you could use it as before. And this is not exactly the same, but I came across this visual by The Economist on the German election, which is happening in less than 2 weeks, I guess, or close to 2 weeks. And I like the idea here. There's a lot of things to see here. So they have these confidence intervals here. And this is actually uncertainty, showing the last forecasts with these strips. And then below we have a tiny bar which shows the actual seat share during the last election 4 years ago. And it was also used or shared at least by the USGS data science for the preprint by Swart et al. Unfortunately, the DOI didn't work, so couldn't have a closer look, but I really, really love this visual when I've seen it. So I think it was, please correct me later on if it's not correct, this was the ggdist package here with the gradient interval. And here you can see also that there's in the mean and the observed maximum temperature and the confidence interval all in one. And then there's a very nice color coding here also with the temperature threshold and the lower and higher temperatures with brownish and blue colors. So there are use cases for these. Okay, next to raw data plots. And we have seen this in the answers as well. So the easiest way to overcome the bars and the box plots, if you don't have thousands of samples per group, is the strip chart or the dot plot. And it's actually not a dot plot, but it's called sometimes the dot plot. It's a strip chart or scatter plot on one axis, where you just draw every point here. And you can already see that it becomes difficult. I added some transparency here with the alpha argument, but you already might have trouble if I ask you which or how much larger is group A compared to group C. But might be fine. Again, depends a bit on what you want to tell with your plot. This is, of course, also important. What's the main point of showing these distributions? I currently also like these kind of strip charts. So it's basically just a different symbol for it, but it's called a barcode plot. And you can still do it with the GM point, so with the same basic ggplot geometry. And the trick here is you could also do it with some lines and stuff, but it's getting difficult. And the trick here is to use the shape 95, which is a horizontal line, and then to make it very, very big. The downside of this is that you cannot control the width and the height of the lines individually, but I actually don't worry so much about that. Then you can still go for lines, but the lines you need way more input, and this is an easy trick. Just turn the points into horizontal lines. Of course, we can also jitter them. So these are the so-called jitter strip charts. A short note here. There is an own GM, which is called GM_jitter. But you could also use the GM point. And then again, with the, you know it already, position argument, and where you have a position_jitter. And now you might wonder, why should I use the position, blah, 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 if there's a GM jitter? The nice thing is, and now I'm hoping I'm correct, that there's no seed option in the GM jitter itself, that you can, oh, sorry, I'm switching that first, that you can set a seed here. And a seed means that we always put the same, have the same random number generator activated, which means if we randomize something, and here we have some random offset to the left and the right to make these jittered strips, we use the same. And here I'm using 2 times the GM point. And if I would not use a seed, the outline of each of the circle would be off from the actual points. And this is the way how I can control it. And also, every time I would show the next slide, these points would move around. And if you're giving a workshop or a presentation, this might be not a good idea. So people concentrate on the content, not on the moving points here. So with the seed, you can control how they look like, which also means if you change the seed to 1, 2, 3, the jitter looks different. So you can also find the optimal jitter because there's randomness in there. Of course, there might be a good combination and a bad combination, and this is not always the same. It depends totally on your data. Okay, going back to the example here. These are also these called jitter strips. Again, a contribution by the USGS here for the 30-day chart challenge. And this is similar to the one I showed you in the beginning for my evolution of the ggplot thing. And yeah, again, it depends what the story is. And I think the main story is really here to show that where the vast majority of points falls along, and that we have many, many outliers here. And then again, clever use of color here also to pronounce that shift. But very similar to the jitter strip is this so-called Zena plot, which, yeah, I'm not even sure if this is an own name. At least this is what Thomas Patterson, the developer of the package, called it, the GM Zena. Also here you have a seed. So you can see again that I'm using 2 shapes, so the dots once, and then on top the outline. And you can maybe see that they are following a bit the violin shape. It's a bit hard to see here. Then we have the true dot plot. It's again, I'm using the one from the ggdist package, but there are other ways to do it. There's a stat dots, and that's how it looks like. So it really stacks up the dots, each observation in horizontally. Again, I'm moving it a bit to the left to make it align with the groups, with the position nudge again. Sorry for the typo, this was copy paste. And if you don't want to move it around, or you don't like this kind of like skewed view, you can also turn on side both, and then you get these symmetrical dot plots. And there's a drawback of these. So you should be aware that these are binned plots, so they bin the data. So this is a very colorful and silly graph here. But what I did here is basically I mapped the shape to the integer number of each data point and the color to the first digit of each data. And as you can see, for example, in group C and group, in all of the first 3 groups, you can see that there are mixtures on the same row. There are 4 and 3 values. So these are binned together, similar to a histogram. This is something you need to know, so they can be misleading, and they are not as honest and as transparent to the data itself. You can then, for example, use the layout weave in the stat dots, where, if I got it correctly, I read a bit about it, I'm not completely sure, but if I got it correctly, it keeps the y-axis. So it's the true y value, but it tries to arrange them on the x-axis in a dot plot shape. And you can also turn that into a B-swarm plot by saying layout swarm and side both. Then you get these B-swarm plots. It's actually also not a true B-swarm plot, or at least I know B-swarm plots that they're really arranged in a line, and then the lines go slightly up, like these emojis, smileys. I think there was also a smiley plot or something someone suggested for these plots. But here you can see again that the y should at least be the correct one. I hope so, if I got it correctly as mentioned. But you still get these violent shapes that you see where most of the data points fall. Now you might be wondering, why is he using ggdis? There's the ggb_swarm package. Yeah, for sure. You can also use the gmb_swarm from the ggb_swarm package. I actually, again, like the ggdis package better. I have the feeling I have more control here, because here you see already that some of these are overlapping, which shouldn't be the case for a b_swarm plot. So if, for example, in group A and group C, there are points overlapping. And you always need to play around with the size and the called CEX. So the size determines the size of each point, and the CEX depends how much they overlap or not. And there's no direct connection from these two, so you always need to do it manually to make it look good. And I always feel like some are overlapping and some others are spaced out, so I'm not always happy with these. Similarly, the ggb_swarm also has a gm quasi-random, which overall looks the same. And here we have the size and the width argument, so you can always control the dot size of growth and also how much they spread. Again, I'm using 2 times the same, and here you can see that there seems to be no seeding because they always draw it at the same position. And again, I'm using a colored point and then a black circle to highlight overlapping points. Some examples. So this is my favorite b_swarm actually. I'm into rap, so I really enjoyed this article by Matt Daniels back then at the Pudding. And it's the number of unique words used by rappers. And this is actually an interactive one, so you can click on these single rappers. And the main point here is that we have a vast group of rappers who use between 3,000 and 5,000 words, and then we have a few which use way more unique words. And this is a fun visualization, and also makes sense to represent each rapper as one single point, because how would you group them together? These are individuals, so you could also show them as individuals. I talked about this graph, the chart type itself, and also this graph in my video for John Schwab's One Chart at a Time video series. Just want to advertise this one here. So these are roughly 50, 60 videos about all the different charts. This was a video series for his book, which came out a few months ago. And I enjoyed it a lot. So every chart type is covered by a different person working in the data visualization, data science business. One fancy b_swarm plot you might know this as well, by Nadi Berma. It's this visualization of the number one. I think it's on number one, at least the Billboard charts. And yeah, we don't dive into here, but you can make also colorful things with these and use colors to encode different variables. And here you see that we also have these red indicators and outlines and stuff, so you can do way more with b_swarms. I use them also here, which I wasn't super happy with the visualization, but I still want to show it because I at least think one can think about it here. So what I did is I colored them based on values above or below the median value. So it's not so important what it shows here, but this is about diversity scores in schools in 2 different years. So the gray one is the previous year or decade, and the upper one is the most recent one. And with these 2 different colors, I can directly also indicate the median without using an additional information, adding a point on top, which would be anyway hard to read. So going back to the overview, it might be still possible to see which are more reddish or more yellowish, for example. And also while reading about the b_swarm plots, I found this comment by Leland Wilkinson. You may know him, important statistician and data visualization expert who also wrote the grammar of graphics, which ggplot2 is based on. And he noted here that we have the problem that b_swarm plots obscure some of the values, and that we should be careful. I also want to highlight the last sentence here. Valid visualizations need to pay attention to the underlying mathematical and statistical models. It is not enough to draw unstructured pictures of data, pretty as they may be. I fully agree here, especially in a scientific context. Of course, if you're going towards something like Nadi did, for example, which is a fun visualization, I think there's still a value of shifting a bit the values to make a nicer plot and visually more attractive design. Okay, finishing up with hybrid charts. I hope I still have a few minutes here. I call it the best of both worlds because these hybrid charts are often consistent of raw data charts and then summary charts, which obviously makes sense. So one of the simple ones would be, for example, to any, doesn't matter if a B-swarm or quasi-random or a jitter or Zener plot, you could add just the summary, for example, the median here again. So we just, again, with the shape 95 can draw a line where the median lies. And of course, we could also make some error bars to indicate the standard deviation, standard error, or interquartile range. So we would have both the raw data, so we could directly see that the group D has a very small sample size compared to the others, but we could also directly see that the group A has the lowest overall median. I used this approach for my PhD diver. So when I was defending my PhD thesis, I had a box plot version, which was pretty stuffed for the paper. And for the talk, I tried to reduce it a bit. So this is what I came up with. So I added a dot for the median value for each of these scenarios. So I had 3 different strategies for the animals to move. So this was a theoretical simulation model with agents. And I had different landscape scenarios, and I wanted to compare them all. And these are 500 simulations. So actually, these are not violent plots, but these are bee swarms, but with very, very tiny dots. These are 500 gray dots, which make up these shapes. And I think they tell a lot of story here. For example, that on the right hand, you see these long bands towards the upper one. So we see why the majority doesn't visit many, many cells. There are many, many runs or several runs, and it doesn't matter which landscape scenario where the animals end up in more cells. And for example, in the middle, you see this nice shift from high values to low values, while on the very left hand, all look the same. I also use this for part of this map here. Again, no, this time it's the Makeover Monday, I guess, but another contribution to one of the challenges. And I just want to draw the attention to one minor detail. So I'm zooming in here more and more. And here I'm again using B-swarm or quasi-random from the ggplot2 package. And I add this median with a dot. I just want to show you here the idea I had. Unfortunately, it became a bit small, but the upper B-swarm points upwards. So every value which is higher than the median, the lines go upwards, and then the other ones go downwards. And the effect wasn't as stark as I hoped for, but because they become very tiny, but I still think this could be an interesting idea also to show the way that kind of like they are going away towards the bottom or the top. But again, keep in mind, if you really want to have quantitative information here, these might be not the best chart type. And in addition, I also use color again to distinguish the two. You can, of course, also add the jitter to the box plots on top. So if you like your box plots, go for them, use them a lot, and inform people how great they are, but try somehow to add the sample size, especially if it's biased. Okay, and it's always nice to have a lower width of these to make the box plots still visible. It's important also to remove the outliers. So you can do this, with, for example, with the outlier.shape setting an A in the GM box plot, because if you would have the outlier here on the top, you would give the impression that you have 2 values, which is actually only 1. So 1 dot would be drawn as an outlier by the box plot, and 1 dot would be drawn for the raw data. And you don't want to have that, so you always need to remove the outliers. And again, I like to use 2 GM points, then with a jitter, so I need a seed again, that I have the outlines, which can nicely indicate the overlapping points here. You can, of course, also combine a violent plot with the box plot, which can get very informative. So for example, for the group B and the group A, or especially for the group B, you can nicely see the distribution with the outlier on top. Again, I would suggest here to maybe remove the outlier and maybe also the whiskers. Then it would look like this, but this depends what you want to show and what you prefer visually. And you could also style it a bit more. So this is more the classical violin plot. If you Google for it, you will find a lot of violin plots which look like these. You can also do this in ggplot. So we use the same color and fill for the box plot. So which means what was the filling which was white before is now the same color. So we don't see the median line anymore. In the median line, we add then with the stat summary call, again with the median function, and then with the gm point. And of course, you can then make the combination of all of these, so violins plus box plots plus jitter strips or B swarms or Zener plots. So be creative here. Here's a version with the Zener plot. And here you can now nicely see how they are better than jitters, because they really follow the patterns of the violin. If you set both to count, for example, you now have these the width indicating the number of observations, but also each of the dots, of course, showing one observation, and you can clearly see the difference across groups. And then in addition, with the stat summary call, I add this time it's a triangle, could be a dot as well, for the median. And finally, wine cloud plots, my favorite somehow, where we have also several things here. So we have first the jitter, where I'm using here the GG halves package, which allows me to have offset jitters to the left. I'm still not aware of any way how to do this with the basic ggplot2 package. Then we have in the center the box plot, and on the right hand we have a half violin or density curve. And again, we have to nudge them. So here, as mentioned, GG halves has a side L, so on the left argument, and we move with the position nudge, we move the half eyes towards the right. I used this also during my PhD. So this is another plot from my agent-based model. And don't wonder that they all look the same. This was on purpose. So this was a model fitting, and I wanted to show that even though the box plots, so here you can see that the box plots look all the same. So the median is the same, the interquartile range is the same, and also the whiskers are the same. The dot indicates the mean, also they are the same, almost, but you can see that we have some outliers, for example, in the red data. These are out of 500, so they are not covered by the box plot, but might be important if you have stochastic effects in your model. And now, why are they called rain clouds? If you flip them around, in ggplot that's pretty easy with a chord flip. You have these half eyes, half violins, which are the clouds, and then you have the dots, which are the rain falling out of these clouds. And this is also what I used for the penguin visualization you have seen in the beginning. So this is from a blog post where I walked through different ways how to build rain cloud plots, and I might have to update it now because I found new neat tricks here. And of course, I just want to illustrate here, you can also add text labels to indicate the sample size and the median values and so on. You could also make barcodes here, which I like, which I have used. And again, with some offsets. And I'm going to zoom in here. So this was the original penguin rain cloud plot, which also got a lot of attention, where I built these fancy Tableau box plots. I'm still not sure if I like them, but I just want to see if it's possible. And then a barcode on top at this time. So if you don't like all of them having together, of course, you can still overplot it. And I have another median indicator with the slab interval from the ggdist you have seen before. So here it's basically all together. Another example for the intervals. So here I combined the intervals with the dot plot. So this is about coffee bean ratings. And the idea was to show each single rating for each coffee bean by a brown dot, which makes sense here. And do not care so much about the binning here because we have a large gradient and the points are anyway integer, I guess. Sorry. And with the interval, I can quickly highlight where most of the points fall. And you can nicely see the differences, for example, in sample sizes between Mexico and Honduras and Taiwan. And then while searching through my old visualizations, I just found two other chart types where I wanted to talk about quickly. Sorry. It was also about distribution somehow, but the first one is this, I still don't know how to call it, lollipop waterfall combination. So the horizontal lines show again in this case, I'm not even sure now, should have written this somewhere, the mean rating, I guess, of each episode of The Office. And then the lines indicate each season of The Office, and of each episode, the lollipops are indicating the single ratings. And here we have some ordering, some temporal ordering. So we start with some season, and we have also some grouping. Each season belongs together. So we can basically, what I've shown you in the beginning for the worlds, do for every season. And I recently found a nice example, which was at least reminding me of that visualization. This is by Lisa Mood, previous Lisa Rost from Data Wrapper. It's again about the German election. And here we have the same approach of showing the outcome. The straight line is the outcome based on the polls of a month before the election, and then we see the single polls indicated by the small lines or bars. And the last one, it's about word clouds, because many clients also request word clouds, because they're somehow, I don't know, interesting. People like to see them and to read them. We have also seen them in the Sli.do tour. And I think, yeah, for exploration, they are fun, as written here in the middle as well. But it's pretty hard to see patterns. So here we have in blue the positive ones and in red the negative ones, and I placed them on purpose in this centered way. But the problem is that we have long words, shorter words, and some are not readable anymore, and so on and so on. And I played around with different ways here. So I stacked them together from the highest to the lowest value. And here, as mentioned, I also have a positive and negative connotation, and fun was connotated as well, negative and positive. So this was basically my threshold point. And here I combine basically the thresholds with a line graph, but still have all the words, and the words are then, again, as in the word cloud, sized by the number of appearances. And with this, I want to close. I want to point you to my blog, where you will find the mentioned blog posts about the ggplot tutorial if you want to know more about ggplot coding, or also about how to visualize distributions. And most of the codes, as you have seen also for this talk, the code is available on my GitHub. And yeah, with this, I want to thank you, and feel free to ask any questions.
Wow. I want to invite everybody. Yeah, no worries. I want to invite everybody who's still got their video off to turn your video on or your audio on and give a round of applause, because this was amazing.
Thank you. It was a pretty new experience. I didn't see any one of you, so I wasn't even sure if Teams was even running.
Were you able to see the little like heart reactions come up
no,
on the bottom of the screen?
I didn't see anything. No, I just saw my slides, unfortunately.
Blind. Well, that was incredible.
Thank you.
So now we're going to go do Q&A. I invite you to either type your question into the chat and we'll ask it out loud, or if you want to raise your hand, you can do so up in the little controls. Raise your hand and we'll make a stack, and we'll call on you to unmute yourself. Does anybody have anything that they want to go right off the bat? Because I have a bazillion questions in my mind, so I don't want to, but I've been talking a lot, so I will hold back.
I have a question. My question is, like, what do you use for your text placement and annotations on your plots, like labeling lines or bars? And I'm familiar with that with like geom text or geom label, but when you're putting your titles and you're like making these like larger graphics that have multiple components, like how are you placing them and spacing them and getting the text looking so good?
Yeah, lots of iteration, actually. So if it's really about specific positioning and so on, it's really a lot of iteration. And that's one of the things where if I don't need the automation and the reproducibility, I'm definitely moving towards now vector design tools where I can place it quickly, and also don't mess around with custom fonts, which is with system fonts getting better, but still a bit of a problem to make it work sometimes. So yeah, definitely something where you can place it by hand, but sometimes, I mean, I still like the way of coding everything, which is the challenge for Tidy Tuesday, where we kind of like was doing it a bit too much also at some point, really pushing it to the extremes. But still, I have several clients who use R Markdown files where they just automatically generate these plots or update the data, or produce 1,000 plots per week. And then you also need to somehow control the label placing with pure code. And I think the only tip I can give, so you mentioned the packages. So ggtext, of course, get to know ggtext. I think most often ggtext is way more powerful than annotate. So try to write small data frames which hold all the information for your labels and then place them. Maybe also they have already the information for the arrows or lines you want to add. And if you want to iterate, it's still work in progress. I'm saying this now for more than a year, but it is the case. We have a small, tiny package, which is called Camcorder on GitHub, which was based on the idea that you can create these work in progress, how we design ggplots step by step, animations, if you have seen them already. But the nice thing is that it directly shows you the plot as it looks like when saved. So you can specify the width and height. And the problem is, for many people also experienced doing the workshops, is that people say like, yeah, but when I save it, it looks completely different than on my screen, which is a pity, because this is something I also did this a lot, like working on the screen in the beginning, and then I was printing it and I was like, what's this? I spent so many hours to get the sizes right, and now they're all gone. And this package allows you to, so it's using the viewer actually. So it's actually saving a PNG file to a temporary folder, and then it's showing the PNG file in the viewer instead of directly showing you the output. So the drawback is if the plot becomes very large, it might also take longer, but might be a way that you don't need to go to the other screen or to the other folder and always double click on the file to have a look if it looks good. But that's basically, doing Hey Tuesday, most of my work, like placing X plus 001, and then I hit enter, and then I go to my folder, open the PDF file, and then I say, oh, damn, wrong direction, and repeat.
Very relatable.
Yeah, unfortunately. I'm not sure. There's an add-in. I never used it, but there's an add-in to place annotations and lines, and so I can't tell you the name, but there's an add-in to do it manually, actually. It will return a big chunk of code because it fills all the arguments you don't need. But if you prefer that, you can try that out. I can have a look if I find it.
That's amazing. I want to ask somebody asked in the chat, Valerie asked, why do you not use variable width box plots? What about mild, quote, possible, and extreme, quote, probable outliers?
Where is two? Here. Yeah, I actually never thought about variable width box plots. I couldn't even say if it's easily possible in R ggplot. Do you know? Is it? I've never seen them in ggplot actually. But yeah, of course, you could do the same as you do with violent plots. You could do with box plots. I think the problem always with these, same with the violent plot, is that you can't extract an actual number of these. So you likely always will end up adding an n anyway. Okay, now you could say, yeah, but with 150 data points in a jitter, I could also not tell you these are 150 or 120. So again, I think it boils down to what you want to show and what's the main message you want to highlight here. So if it's really about, is it important? And I don't think it's important to show that they are 148 versus 150, but it's more important to make people aware of it. And I think box plots with different widths, depending on the sample size, are doing exactly that. So I would definitely consider them. I'm not sure if they're doable in ggplot. So if you know, please tell me. Never played around with these. What about mild and extreme outliers? Yeah, so this is a stats question, obviously. Yeah, so I got trained to always keep the outliers as long as they're part of the data. So if I don't know that the person who messed it up or the program was reading in something wrong, it's not an outlier per se, but it's an outlier in the world, but it's not meant like, okay, I removed that so my prediction gets better or something. I'm an ecologist, so we're dealing a lot with outliers. And yeah, sometimes it's also interesting to have a look at the outliers more specifically than to the mass of points. So, but I can't tell much about possible versus probable here. yeah, I would never, I rarely remove them because I don't also have no reason for them, but because I'm not training prediction models and stuff. Then it's a bit different. Sorry for that.
No, yeah, that makes sense. I have a question actually. And again, if you're interested in asking a question, you can also raise your hand and unmute yourself and ask in person. So I have a question that is less about R and more about process. So you just showed us like an entire taxonomy of options, and I love seeing all the options. And I'm wondering what question you ask yourself or you ask your collaborator when you're trying to decide which option works best for the data set you're working on. Like, is there like a series of questions that you ask yourself? Is there somewhere you start? How do you begin making those choices?
Yeah, so there's definitely a series of questions I'm asking, and I think everyone making plots, making charts should always honestly ask themselves, because I mean, I'm in the same position and I know kind of like I collected all data I want to. So there are two extremes, basically, at least from a scientist's perspective, I know personally. So it's this one like, okay, I don't want to look too close at my data because I know there might be flaws, which is a bad thing because you should not ignore them. And then there's the other thing like, oh, I collected it so hard and I want to show it all to you. And most people only care about 2 of your variables, not 20. So this is the first thing. It's hard, but it's reality. Unfortunately, as mentioned, I did the same things. So this is one of the questions, maybe asking yourself or just reminding yourself that you always go back and be aware what's your source of data and what's the quality of your data. So it's good to drift away from the original question, but if you're always subsetting at some point or transforming, you should always keep an eye on what your original data was. And then for the stories, for the questions, it's about mostly the audience in the story for me. So for my few years of work with clients now and also with colleagues, I often realize that people just visualize for the sake of visualizing, which might be okay in some circumstances, but especially if people ask to improve something, it's hard to give feedback beyond some personal design choices if I don't know what the story is about and what's the audience. So it's really, for me, it's the first question is like, I often get requests like, yeah, how can I make this better? And I'm like, I don't know. Tell me first, what should I see here? And I mean, if I look at the graph and I can't see the main story, this is already a sign that you should rework it. That's the first thing. So always look like a naive person or go to your colleague next room and ask them what they see from the picture without telling them what you see there. And so this, I think, is the main question still. I mean, might be very obvious, but I think it's often missing, that you directly jump in and miss that. And then, audience. I mean, the whole box plot discussion, for example, it's all about audience. And I'm not a fan of strict rules, and I really don't like gatekeeping and stuff. So I pretty much against these, everything should be bars and never do this and that, never use spirals or never use circles to visualize areas and stuff like that. Because there's a lot going on also with attention and variability. I mean, if we would all have tufty box plots out there which are black and white, it would be very boring, and we are not bound to these constraints we had back then that we need to print them. And I think social media and the internet per se is a very colorful place, so I don't mind seeing them. I think if you're using uncommon approaches, make sure that you explain it to people, written form or spoken form or whatsoever. So, and also if you criticize them at the same time, try first to think about that there might be use cases which is not yours. So I often see like, but that's a bad chart here because you can't see this and that. Yeah, maybe the story is not to see this and that. The main story might be something different. Might be the overall pattern in distribution, not the quantitative value. So that's why I also was kind of like going forward and back with the dot plots and B swarms, because I think it's a valid point. At the same time, if I know that they might be slightly shifted, I don't see the major point here if I'm not making the bins too broadly. The other question, which one then I pick in the end? I mean, this is often then really I don't know, maybe even daily mood. I don't know. Same for colors sometimes. I mean, there are clear emotional values and about variability. So, I mean, if I'm working for reports, public reports, for example, we try to avoid having only bar plots all the time, right? I mean, because if you have 100 pages of a report, I strongly believe that people get bored by them and they don't look closely anymore. I might be wrong, so it's not science, it's more my personal perspective on this. Yeah, not really a clear answer here. I mean, the major reason for raw versus summary is always the sample size, of course. I mean, you can't draw jitters for thousands of data points. Also gets at some point problematic computationally, but you also can't see them anymore.
Yeah, totally. I remember trying that once with like 1,000 data points, and
it takes the
like,
time.
broke.
And then I always draw them twice, so it's double the numbers because I make the ring on top. Yeah, maybe a note there because I didn't tell it. You always can use the shape 21 in ggplot. This is one of only a few I know by mind. So if I need to Google for something, most often it's definitely ggplot shapes, at least 3 times a day. Oh, now I lost the track. Yeah, why I'm using 2 GM points and not a different shape. For 2 reasons. If I'm using, so the GM point, the shape 21 is the one with the filling and an outline, and you could make it transparent a bit and still have an outline, but you first, as mentioned, I'm a perfectionist, so the outline somehow gets some artifacts and also gets some, I don't know, looks weird if you zoom in. And also if I have overlapping plots, still I have the outline behind another one, so the outputs, the outlines vanish, and if I just throw the circles on top, you can see all the points very clearly. That I missed during the talk. Yeah, so that's why I'm doing this extra effort of sometimes even adding 3 times the same points on top of each other. So having a white one and then having a transparent one on top and then having the outer outline on top.
Yeah, that makes a lot of sense. That's a lot of stacks.
Yeah.
So somebody in the chat, Haley asked, what are your thoughts on using log scale plot axes for public-facing data? There's more to the question if you want to read it.
Yeah, I see it already. I don't need to read it out. Okay, first let's start with the log scale. I mean, yeah, I'm coming from the science perspective, so I'm used to seeing log scales a lot. I was trained with log scales a lot, but this is basically the same idea of, yeah, assuming everyone can read a box plot, maybe even more difficult because there's this transformation. It's just not only repeating and reminding what these symbols mean, but also actual brain exercising. I'm also a bit torn apart between, there are basically 2 schools. There are these schools who say, like, don't do it because you're confusing the people, don't do it. They don't get the message. And then are the others like, okay, if we would never show them things they don't know, we would never move further. And I'm definitely tending towards the second group because I always think we need to move further. At the same time, I definitely see the point of people seeing log scales, not paying attention to it that it's log scale and getting their story out of it without realizing it's log scale. So this being said, the first thing is like prominently make people aware it's log scale, maybe add a small text to explain it. A good idea is always to add several tiny ticks so that you see that the spacing gets larger and then it gets smaller again and larger again. You might have seen this. It's also possible in ggplot. Also use good labeling here. So it's often good to say like this is 2 times the one before than having cryptic numbers there. And I think now with the coronavirus pandemic, again, it's just my gut feeling, not science, but I think many people now have seen log scales. So I really hope that exponential and log now, at least for the people who want to know it, is something they are more familiar now with. So I think a good thing about this pandemic is definitely data literacy, data honesty, and data visualizations per se, how to read them. And if you definitely know them, I guess, John Byrne Murdoch from the Financial Times, who did all the great visuals, and he was getting a lot of feedback, negative feedback on the log scale. So he was also sharing his thoughts on it, and he even made a video explaining it, why they have chosen it and how to read it. I think this is the best way of informing the crowd why it's used, because there was also basically the people telling him that he's using it on purpose to mislead people, which is obviously not the case. But yeah, you could also say it's intention that you transforming your data in a way that people don't see the actual data. So, and I think it's definitely important to get these people on board, that they don't think you are doing something harmful, but it's for a reason here. Yeah. The next question from Heidi. Can add elements to the design of the plot to help viewers correctly interpret the log scale. Okay, yeah. This was mentioned with the ticks, and I think also the labeling is important. So use good steps, good breaks, and then also, I think 2 times, 3 times, or percentages labels often help than absolute numbers. Do you know of alternative accurate ways to display data across a wide range of scales that don't use log scale axis? Yeah, it depends a bit what you want to show. I mean, if it's about a true scatter plot, so 2 continuous axes, X and Y, then it's a bit difficult. I mean, you can still zoom in stuff. I mean, again, depends a bit what's the main story, because if you zoom in, you have a subset, so people might focus more on the tiny values. If this is what you want to talk about, it's definitely good. If you want to talk about large values and then you show them an inset and they are focusing on these tiny values, you completely lost them because you don't actually care about the small values. Sometimes it might be not even important to show these, so just show them that there are many. So if it's not needed to show the individual values, or if you could think of having a second panel where you show some additional information, you could have a scatter plot. And on the other hand, for example, you could have a binning again, for example, a tile grid or a hex binning. So it's pretty easy in ggplot with the GM hex, for example, where you have then grid cells which are colored by the numbers of points in there. And then you directly see often a bright, depending on which color palette you use, but a bright yellowish if you use Viridis by default in the 0, 0 corner, where most often you have the bias when you're using log scale. If you only have log scale on one axis, for example, and you have bars, you can definitely not use log scale and make 2, 3 panels out of it. So basically showing the 3 large bars and then grouping the others together to another bar, or showing all of them because they get very tiny, you can't compare them. Then again, it depends. Is it important to compare the small bars, or do you really just want to focus on these big bars and how much bigger they are? Then don't use a log scale because you want to show how big they are. You could even argue in the context of a bar plot, you should never use a log scale because, as mentioned, the length of the bar is the thing which encodes it. And if we transform it, it's visually not straightforward to interpret the length of each bar. So there might be even people who say, don't ever use it. So I would not use a log scale, and I definitely would aggregate it to others most likely, and then have a second plot where I show the smaller other groups as a single plot. Yeah.
It's interesting, actually, just to stay on this question for a sec.
Yeah, sure.
I think I know where this question came from, because Haley and I and C are working on a project that involves showing basically the spread of the volume of all the pools of water on Earth. So how comparing the volume of rivers to the volume of ice to the volume of the oceans, like and the volume of kind of it spans 6 orders of magnitude. And so Haley, I'm sure, has been thinking about the 18 different ways that she's tried to show not just how big are the oceans or how big are rivers in terms of 1,000 cubic kilometers, but instead the point being show how different they are. And I think that's one of the big struggles that I think this question is coming from. And so your point of maybe breaking it up into chunks might be an interesting strategy there.
Yeah, I think definitely zooming in is a valid option here. So you could even think about making some more abstract things, like, okay, grouping them together and then show the big differences, and then say, okay, now we're looking more at the tiny patterns. But yeah, it depends a bit on the data. So I mean, I'm happy to brainstorm with you at some point, but now it's a bit difficult to imagine how it looks like. But yeah, might be.
I'll take you up on that.
Yeah. Haley or C, if you guys have screenshots and you want to put them in the chat, I feel like some people might be interested in seeing them. Yeah. Okay, I see 2 other questions in here if you feel like you're ready to move on, from Lindsay or Valerie. Lindsay is asking about animated plots. Do you ever find them more useful, interactivity, stuff like that?
Yeah. I did animated plots more for the sake of fun often. I think they have an added value. So why I mostly don't use them in the end, it's because they are pretty good for social media, but not so much else, I'd say. So I don't think people, I mean, if it's a very interesting animation, they might stay, but I think if it's in a vast blog post, you have 50, 40, 80 tabs open, and then you see an animation which takes 3 minutes, you will not spend the time likely. So I think static plots often are then easier and faster and quicker for people to interpret. Also, with animation, I have sometimes the problem, so from a ggplot point of view, that the quality is not as good as with the static one. As mentioned, I'm pretty much into clear shapes and stuff, so I'm zooming in and things. And also for animations, I often have the problem that I cannot stop. Depends on what kind of. With the GIF, it's problematic that I cannot stop and have a closer look at the data. So if it's like, so if you're making animations, make sure that the last image at least is still for a while that you can have a look at there. But yeah, I use them. So I think there's lots of good opportunities to use animations. For example, everything which has a time perspective. Revealing patterns over time, it's spectacular if you're using animations. So for example, this famous and very sad headline or front page of I think it was Times, right, with the COVID numbers. No, it was not even the numbers, it was unemployment, I guess, right? This red line. Anyway, so if you have kind of like, you have a line chart which has a kind of like some fluctuation, and then at some point very recent, or you could also use now climate data, and then you see a stark rise in the data, I think it's more powerful if you reveal it over time, and maybe even if you then zooming out and out and out. So first you shrink the scale, and then you get bigger, bigger, or then even maybe it's leaving the grid and it's completely going to the stars. So I think this might be valuable, that people focus also on the low values and not only on the most recent ones, so that you really have these stark contrasts. And also spatially, of course, I mean, often also time. So thinking about my topic of moving animals, it's perfect to visualize these kind of data in an animated version, because we have so many data points, it's hard to follow them, especially if you have ranging animals. So they're going back to the same plot. So you have a lot of overplotting going on. So you can make even vanishing lines so that you only have the trajectories from the last few hours or days. So I think there's lots of potential for animation, but with the drawbacks that they are hard to print. You need the people, might be attention grabbing, but then the people also need to stick to them. And I think someone mentioned ggAnimate as the favorite package, and I have to say I struggle a lot with this package. Especially of getting the things right, of the design part, not making it work, but more than, okay, placing labels and stuff because they look different and so on. That's from a technical thing. This might be the main reason why I'm not using animations. I'm mostly using animations for the design processes, which I've found also somehow interesting, and people like them to see that I'm not sitting down at my computer and thinking about like, yeah, let's do I don't know, whatever chart, and I get everything right, but there's a lot of iteration as well. So, yeah. And there's some more. I also struggle with ggAnimate, yeah. Yeah, I mean, it got a rework and it works pretty well, but especially, working with custom fonts and so on, and I'm doing a lot, so I'm never using the default fonts, and I also struggled today. I just want to make a GIF for the workshop quickly, and then I also had a problem of fonts not contained and stuff like that. And this then eats up all my time. So it's really like, okay, I just do the quick animation and I'm basically done with the coding in 30 minutes. And then I spend 3 hours on getting these tiny details right, which is frustrating. We have one more question by Valerie, right?
Yes.
Mm-hmm. What are your thoughts on having a wrinkle chop gap in axis for example, to show all values, but there's a single point which is an order of magnitude higher than all the other points. Yeah, so yeah, no, don't do it. That's the first answer here. So there's a pretty, I mean, yeah, again, something you often see out there in the wild, and they're often requested, and if you can avoid it, don't do it. Let's put it like this. Again, no strict rules here, I'd say. You should definitely not do it if you have length encoding, so bars, lollipops, and so on, because we have the same issue, right? We have 300, 400, and we have 5,000, and it looks like 600. So it's just doesn't transport the story you have. So your story is, there's a big difference, and then you shrink the difference and put it away to show there's a big difference. You minimizing the differences. So now it depends what's the single point, if this is an important one or not. So I mean, is it something you can remove? Maybe you can just make a note, like an arrow way more there. You need to scroll like 500 times as far to see the last point. So I think something like this, like, okay, I would need 3 meters of paper to show you this point. Like a fun note on that could also something which people like, wow, that far away is this point, might be more valuable than having 500 points clustered together in one point on the other hand. If you have to shrink your axis, yeah, I mean, I'd say from the advice, it would always say don't do it. But if you, for some reason, decide to do so, again, make it prominently, not a tiny dot, and then you're jumping with the numbers. But if at least make it prominently. I'm not sure if you realize it for the B-swarm plot I've shown you with the wrappers, the unique words of the wrappers. There's also a tiny gap in the y-axis in the end, which it's still one of my favorite charts because I just like the fun of it. But yeah, this is something you could maybe criticize here. Otherwise, again, zooming in might be the best, like showing the one in relation to the whole other group and then show all the others.
Yeah, that makes sense.
Yeah, that's good.
I think we're a little over our time, so we should probably wrap things up. But it's been really incredible. So thank you so much.
Yeah, thank you. Glad you liked it. Yeah, go through the codes if you like. Have fun with it, and curious to see then all the other non-bars and non-box plots.
Totally.
Yeah.
All right. Well, before we do quick announcements from CDI stuff, I want to invite everybody to unmute yourselves again and give a round of applause. Maybe unvideo, you mute yourself, and I'll take a screenshot. Guys, thank you. Amazing. All right. With that, I think we're going to.
I just saw I wasn't visible. Sorry for that. My camera turned off. Oh, sorry for that. I was kind of doing all the kind of stuff here. No one is seeing me. Hello. Bye.
Hello again. All right. So, Katie, go ahead.
Yeah, thanks, Ellen. And thank you, Cédric. That was incredible. Hi, everyone. My name is Katie Trickey, and I work for the USGS New England Water Science Center in the Hydraulics and Hydrology section. I'm one of the organizers of this group and going to share the latest announcements with you. If you haven't already, then please check out our Microsoft team. Amy has already dropped these links in the chat for how you can join this team and connect with our community. More information about it can also be found on our Confluence wiki page, and that link is also in the chat under the How We Connect section. We also have a really fun activity called Introduce Yourself with a Viz, which you can find in the Meet and Greet channel on this team. If you don't have time to create or find a Viz, then no worries, and still please feel free to introduce yourself because we are excited to meet you. All right, now over to Dion.
Thanks, Katie. Hi, everyone. This is Dion Zawani with USGS Cloud Hosting Solutions. A couple of housekeeping items before we close out. Like Katie mentioned, please join us on the CDI Data Viz Microsoft team. Introduce yourself via the meet and greet channel with your own visualization. I saw a lot of questions in the chat about the recording for today. We did record today's webinar, and it will be shared through the listserv and posted to Teams and the collaboration areas Confluence wiki page. So you'll be notified via those channels when it's ready to go. And then lastly, as always, we encourage those of you who are passionate about DataViz and are interested in contributing ideas or feedback to reach out to any one of the planning team members if you'd like to join in our efforts. And our contact information is posted on the wiki as well. We always encourage and welcome additional perspectives and ideas. And with that, again, the organizers and I want to thank everyone for joining today. A huge thank you to Cédric for the great presentation and very lively Q&A session. Like we have done in the past, the planning team will be sticking around for a few minutes, maybe to hang out and chat about the content today or what folks are working on or any ideas for future webinars. So feel free to stick around and unmute, turn your video on if you'd like, or again, you can contact any one of us privately via our contact information on the wiki. We're excited to meet you and hear what you're working on. So we'll stick around. Thanks again, Cédric, and to the rest of you, have a great rest of your week. We will see you next time.